Do you see though, if you're going to go from here to here, you've got to figure out what this angle is right here. You got to know what that angle is for you to be able to set up the angle, the side you want, and this you know, right? You want this opposite, you know the adjacent, you need that angle. Do you see that?
Yeah.
Do you see that? No? Okay, so let's look at this picture from the top on the board. Here's the edge of your table. Well, here's your table. Okay. You were able to measure from here to here to be 11, right?
Yeah.
Okay, 11 inches. You know that distance. You want to know this distance, which we're calling D. And so to create a right triangle, you're going to need to know what this angle theta is. Right? So look at this. If you set this up, if you know this angle, then tangent is this over this. But you need a good measurement of that angle. Did you all get something yet?
Yeah, we.
Did you redo it?
Yeah, we got 65.1.
So right around the same?
Yeah,
Okay.
it's off by less than 1.
Okay. All right. It's close. Yeah, you're done. What did you all get it? Angle? Or y'all? Did y'all get something?
Everything just said 45.
So I don't know if we did it right.
You did the whole. What do you mean the whole thing?
That these two from here.
This whole side we measured going down, that's 55.6.
Okay.
And then we just said 45.
Why did you do 45?
We just chose an easy number.
But you don't know if that angle from that corner to here. You don't know if that's 45, right?
We used that, right? That's what we just did.
Oh, you did? Okay, so it looked like 45 to you?
Yes.
Okay, if it looked like 45, then that's fine.
Whenever we did it, then our answer was the same, like was the length. Yeah, we got 55.
Which it should be. If it's 45, it should be the same. Yeah. Okay. All right. That's what we wanted to do. I'm going to say another minute or two. 94. So where's your triangle that you drew? So what's 60.7? What is that?
The distance from this to that.
From here to that end. Okay, and then you measure to what point? To that, and what angle did you get there? 50? Is that what y'all measured? 50 to there? And then you said 60.7. Let me just make sure. You should have use cosine. Why'd you use cosine? Let me look at your triangle. Let me see your triangle. You measured this side to be 60.7, right?
Yes.
Then a point over here, you measured that. This is what you want, right? Call that D. And then you measured the angle right here to be 50. All right. So if you wrote down sine or cosine? Cosine? If you wrote cosine of 50 degrees, that's equal to this side over this side. But you don't know this side, right? So you don't want to use cosine. How about sine of 50? That's this side over this side. You still don't know that side, right? So not sine. How about tangent of 50? Tangent of 50 is this side over this side. That's what you want because this has the unknown in it, right? Okay, so you should have this equals D over 60.7. And now just multiply both sides by 60.7. Tangent of 50 on your calculator. So try tangent 50. And then multiply that by 60.7.
We have an answer.
Times 60.7. 72? Okay. All right. All right. We're going to wrap it up. Did y'all get something yet?
We were taking a shorter length, so that's why we couldn't get it. We were taking a shorter length. So we should be
You were doing what?
we're taking a shorter length.
You want to do a longer one to be more accurate.
Yeah, that's why we couldn't get the accurate
Okay.
one.
Okay. But you all understand the triangle that you set up there. That's the most important thing. Okay, let's go ahead and get back to lecture here. So a couple of things about this little activity. using the tangent function is probably the most important thing, because you need to see that tangent of an angle relates the opposite and the adjacent side together, and when you draw your triangle, that's what you are working with. You're working with the opposite and the adjacent, not with the hypotenuse. If you were working with the hypotenuse of that triangle, then you'd be using either sine or cosine. Now, I measured with this yardstick. I got, measuring from the little like bumper edge on these, I got 50, hold on. I got 59.875. So it was like 59 and 7/8 of an inch. But I think you could argue that these tables are 60 inches long. So if you got close to 60, good. If you were off by, you know, let's take, who wants to volunteer their answer that was not within, who wants to volunteer an answer that was off, that was not 60?
Well, we got into the 100,000.
What'd you get? Okay, so one group got 55.6, right? So what's the error here? What is the error? No, I'm saying like percentage-wise. What is their percentage of error? So the way we find the error is we subtract the true and we divide by the true. The true length was 60. So take that, what's that, 4.4? Divide that by 60, and you get approximately 0.073, so about 7.3% error in that, which maybe in some applications is acceptable, and in other applications it's not, right? If you're building a yeah, if you're building a, I'm trying to think of something that really doesn't matter. The only thing I can think about is the tree house I built for my daughter a few years ago. It's like, just get the boards, make sure they hold, and you know, it didn't matter. Measurements really just didn't matter. That's okay to be off by 7% on something like that. If you're building, you know, aircraft bearings for an engine, you can't be off by 7.3%, right? You have to have a little more precision with that. So, you know, error is okay in certain applications. All right. I have another problem that I want us to do. This one's a little bit more difficult, okay? So let's do the river again. You know what? I don't know if I want to do this one. Yeah, let's do this one. Okay, so let's say that with this particular river, it's weird. It's like this. Okay? Yeah, something like this. It's like it's like an intersection, a river intersection, okay? And you're here, and you want to measure to this point right here. So let's go A to B.
So, what are restrictions?
Pardon?
Restrictions of travel?
You can move anywhere over here.
Only in the one quadrant there.
That's right. You can only move over here. You still just have your tape measure and a protractor. And these are not, like, this is not 45 degrees. It's, you know, in fact, I'll do this. I'll put that there.
Why don't you just make the original triangle from point A to a point directly in front of it, like going up, find the distance.
Where? From this
Like,
point?
if it was the original, like original problem again, like the first one,
Uh-huh.
just make a point like
We
directly
have a
up.
value
Yeah,
for that.
value for there, and then.
Oh, you mean go somehow to here and then just make a triangle?
No.
You see
Like-
where A is?
Yeah.
But it could be.
Oh, over here.
Okay, yeah, and then
Oh, you
make a
said,
triangle there.
yeah, okay, so I'll put a point over here. Let's call this point C. I'm okay with this. Now what?
Make a triangle.
Then you make a right triangle going directly up.
From here to where?
C to B will be the hypotenuse.
C to
A will be
B.
the lower leg, and B to A will be another leg.
No. It's not what, I was saying like the original, like pretend that that's just one river. and you were just making the original right triangle.
Like here,
Yeah, and then you find, or. like going
and then go
A-
from here to here.
No, once you
Yeah.
are, I
There's
don't
some
know.
serious measuring.
Yeah.
It made sense in my head. I don't know anymore.
Okay, so how much time? We have 9 minutes? I'm not saying that was wrong, but since, if you clarify it in your mind, you can express it, let me know.
Trial.
Any other ideas?
Mr. If we do it the same way he was asking us to do, if we go that side and we measure that part, isn't that part and that part going to be the same?
Where?
If you make a triangle in that part?
Okay, you want me to do this again?
Yeah.
Okay, all right, so here, C, and then
And you make a right angle from the top.
you want to go up here?
Yeah.
Okay. To where?
But then coming down back to A.
Okay.
Make a right triangle. Yeah.
Okay.
And then if somehow we measure that distance, isn't that distance going to be the same on that part and same?
No,
on
no,
that
but I
part?
want the distance from here to here.
Yeah, that's different.
Oh,
Yeah, I want the I don't want the distance across the river. I want the distance from this point to this point. That's different, right?
Do you see what I mean? Oh, this is what we did.
Yeah, because if I just wanted the distance across this river, then this point doesn't matter if it's here or over here, right? Yes. Do you have a better picture?
This is what I was saying. So this is like the original. So we approximate, or we make an angle here. Let's say call this 10 feet, right? We approximate this angle, find the distance here, and from here we could approximate the angle from here to here, and then we just find the hypotenuse.
Okay.
And that's how we.
I think that's reasonable. I like that.
That's what I was trying to explain.
Is easier to understand with pictures,
Yeah.
which it, understandably. Okay, so I'm going to do a slight variation of what you're suggesting. All right, so right triangles we can deal with, right? And we can measure angles. We're allowed to measure these angles. All right, so what I'm going to do is connect from here to here, right, like this. That's a right triangle, isn't it? Y'all agree?
Are we supposed to make the point across the boat that we can't cross?
No, no, no. I'm just saying that's a right triangle, right?
Oh, yeah.
That's a right triangle?
Okay.
Okay. I can measure this angle. Agreed?
Yes, you can use the cumulative property right there, whatever you call it, but to where it's the same always as the angle falls.
Well, I have my protractor, right? So I can draw, and I can walk this off, and I should be able to measure this angle. Agreed? All right. Then, here's another right triangle. Right? Here's another one. And this is some angle theta, right? And the other triangle looks like this. Is that theta in there? Is this also theta?
Yes.
Are these angles the
No,
same?
no, they're not.
These are not the same angles, are they?
no.
These are not the same angles, so I better call it something different. All right. What can we measure on these triangles?
We can measure the angle with the B point, we can measure that theta rate, that rating value, or whatever we make it degrees.
This, right? I can measure that. Okay, so let me get some red here. I think I might run out of time. Red. I'm going to box that up because I can measure that, right? Okay. Any other sides or angles to these triangles that I can measure?
A to B. You can measure the distance between B and A, but I do not yet know how that plays in.
Zach,
Yes.
please leave. Please leave the class. Okay. You can measure which side of which one?
A to B, B to B.
A to B. Which is it on one of those?
It'll be a mid value.
It's somewhere, it's like in here, right?
We're right there, yeah.
Okay, so let me put that here, and then we'll call it, let's just call that X. How about we call that X? I'm going to leave it in red because I can measure it. Yeah? Okay. Anything else? What am I interested in?
Well, you can also measure opposite side.
Or what am, in my pictures, what am I interested in? What distance?
The distance between A and B.
Okay, so that's the hypotenuse of this one?
Yes, yes, that's
Okay,
correct.
D. All right. So in this picture, that's here, right? That's D. Anything else that I can measure or can I measure from here to here? Not easily, right? I mean, I could do what was suggested. I could go to a point here, and I could find that, couldn't I? Yeah. That's the problem we just did. I could do that. All right, let me try and fill in a little bit on this triangle. We're going to run out of time. I know I'm not going to have enough time to do this. Let's say that we measure. Let's say that we measure some things and write and fill them in here, and it might help us see how we can do this. Come on, Zach, let's go. Okay, let's go. Okay. All right, so I'm going to do the same picture over here. Let me give you some values here. Here's D, and then from here, let's say we measure this to be 40 feet. And let's say we measure this to be 25 degrees. And what about this angle here? Y'all told me that I could measure that, right? Right? You said this angle right here? Both of those I should be able to measure. Yes. So that's beta. Let's say I measure that. Is it going to be bigger or smaller than 25?
Bigger. It's going to be bigger.
It's going to be bigger. So how about we use 36 degrees? Right? That's what we've got. So I'm giving you a specific example. Like we got out there, we measured 40 feet, measured the angle 25, measured the angle 36.
How did you get the A angle value real quick? Where'd you deduct that from, just real quick?
How would I be able to get it?
Well, I know you could get it from what we talked about using the other way that we spoke about prior to this.
No, it's the same way you did on your table.
Yeah.
Like
Okay.
you would just use a protractor to get that angle.
That's what I was thinking.
So protractor gives you these two angles. Tape measure gives you this side.
Okay.
And I guess my question is that enough information now to be able to get D? Yeah, maybe, okay? This looks really like maybe it's not, but let me put something else here. Do you agree that this side is H? I can call it H, like height, okay? And that height is the same for both of these. Okay.
Yeah.
Let's try and just write some information down. I am going to run out of time, but let's just write some information down. Can somebody give me a relationship between anything here, like using a trig function?
You can use the tangent function.
Tangent function for the 36?
Yeah, you can get H, right?
Well, but what do we know about 36? We know this side right here I've labeled.
Well, we don't know the lower value, so we can use it for the 25. Well, no, we can't. We don't have the full value.
Do I know what tangent of 36 is? It would be H over this, right?
Yes.
But I don't know that, do I? So I don't know tangent of 36. What about opposite and hypotenuse? Right? So would this be legitimate for me to write down? Sine of 36 equals H over D. Okay? Remember, we're trying to solve for D, right? Let's not lose sight of that. All right. Any other relationships that I can come up with? Okay, it's time to...
T over 40.
Everyone turned in something? All right, how about you work on the homework for this section over the weekend? Think about this problem. We should be able to figure out that distance, all right? But you're going to have to mess with it. You can keep, the protractors are free. You can have them, okay? Yeah, if you need to take a picture of the homework, you may. I'm going to work on all the homework videos tomorrow. So by tomorrow afternoon, hopefully, all the homework solutions will be updated. And we'll come back and we'll start class next time with this problem. See if anyone got it over the weekend. Or tells me that we need more information.
You want us to do the silence though?
I'm going to do it off the quiz. Yeah.